Shadow, 이거 뭐야? What is this?
Hi, my name is Shadow, and I'm the world's first canine linear algebra student, and that is my favorite treat. See, there I am, doing anything I can to get that treat. What if I sit down? Huh? What if I stand up? You gonna give me the treat? Huh? Loser. Anyway, I had a dream last night that I was back in my hometown in Korea. My owners back then weren't very nice, and then I suddenly woke up because I had remembered the name of the company that tore me away from my family from a very young age. Mini Pups Evil Incorporated. Let's go back to where it all began. It started on a day at the park.
I wonder if we need the props.
That's one of my humans. His name is Juwan.
Like putting a pen around Shadow's ear.
No.
You know, we can film that at home though.
Yeah. Don't bother her.
You're the one bothering me, stupid.
You might have to carry her at some
Carry?
point because it rained today.
You better clean my paws when we get back inside. Hey, watch those hands, watch those hands.
Park?
Yeah.
I bet.
Come here, Shadow.
I'm coming. Oops, not that one. I have to say, the worst part of that day was having to pretend that I was learning linear algebra from this loser. Bro, I learned that while you were still learning how to count.
Shadow,
What?
you have linear algebra.
Okay.
You have matrix. You have some numbers inside the matrix. You know? And you have like these numbers, and then you have a column next to it.
Uh-huh.
And then if you matrix multiply everything, and then you know, get some numbers
Okay.
on the side too. You get another
Okay.
column. Shadow, you get another column, Shadow.
Oh, I hear you.
She's sleepy.
Nah, I just know all this already.
Oh shoot, there's cops. I'm scared, Shadow.
You should be. This is illegal. Just act normal.
Now we're going to get into eigenvalues and eigenvectors, Shadow.
Not that normal.
Basically, the idea of an eigenvalue is to have matrix A
Uh-huh.
times, and this only works for square matrices.
Okay.
Matrix A times a vector B equals a scalar constant lambda times that same vector B.
Oh, wow.
If such a scalar constant lambda and a vector V exists, then that scalar lambda is called an eigenvalue, Shadow. Shadow.
Oh, okay.
Shadow, it's called an eigenvalue.
Oh, no,
and then
I
the
know.
eigenvector is the V.
Okay.
Did you know that?
No, I didn't know that.
Where should we go?
Let's take a walk. Let me teach you about how linear algebra can be applied to the field of genetics. First, a story. I was bred by an evil corporation called Mini Pups Evil Incorporated. They do weird things there, man, I'm telling you. I was one of the first to be bred from their evil schemes. Generation 1, they called me. Anyway, my lifelong goal is to one day find the Mini Pups Evil Incorporated headquarters and save all the imprisoned puppies, big and small. So I've been preparing for when I do happen to find the headquarters, so that I'll be able to calculate exactly how many big puppies and how many small puppies I'll need to rescue. But why do you need to do that? Duh, so that I know how many Uber X's and Uber XLs I need to order for the escape. Now you stay quiet and listen. You already know how to diagonalize a matrix by finding the eigenvalues and eigenvectors. That's good and all, but you should really learn how to apply that to genetics. Let me teach you. Take Mini Pups Evil Incorporated, for example. They use a specific breeding program that takes advantage of our genetics in order to produce mini puppies to make a quick profit. You see, being mini is a recessive autosomal trait, which means that the gene for normal size dominates the gene for mini size. Mini Pups Evil Inc. breeds every dog in the population with a mini pup in order to maximize the number of mini pups. I know, gross, right? Anyway, linear algebra can help us through what are called transition matrices, which, when multiplied onto a vector of partial fractions of the genotypes, outputs a vector of the genotype partial fractions of the next generation. Now, we have ourselves a formula for the genotype partial fractions of any nth generation of puppies. It's just the transition matrix raised to the nth power times the original vector of genotype partial fractions from the original parent population. But there's just one problem, which is raising matrices to a power, and that is where diagonalization can help us a lot. Let's look at an example. we first need to find the transition matrix for a breeding program where every single dog is bred with a mini pup, whose genotype is always little a. Breeding any dog with a mini pup is never going to yield a dog whose genotype is big A, so we know that the top row of our transition matrix is all zeros. Next, we consider how to breed a carrier of the mini pup trait. Any big A dog bred with a mini pup will always yield a carrier, so we put a 1 in that position to denote a 100% probability. A carrier bred with a mini pup will yield a carrier half the time, so we put a 1/2 there. And a mini pup bred with a mini pup will never yield a carrier, so we put a 0 there. Finally, we consider the last row, where we consider how to breed a mini pup. A big A dog bred with a mini pup will never yield a mini pup, so we put a 0 there. A carrier bred with a mini pup will yield a mini pup half the time, so we put a 1/2 there. Any mini pup bred with a mini pup will always yield a mini pup, so we put a 1 there. In the end, we're left with the transition matrix of 0, 0, 0, 1, 1/2, 0, 0, 1/2, and 1. Next, we use ordinary linear algebra methods to diagonalize our transition matrix. Specifically, once we find the characteristic polynomial of our matrix, we recognize that our eigenvalues are 1, 1/2, and 0. Next, we subtract our eigenvalues from the main diagonal of our matrix and find the null spaces of our matrix in order to find the eigenvectors corresponding to each eigenvalue. After we find our eigenvectors, we construct a matrix consisting of our eigenvectors as columns, construct our diagonal matrix, and compute the inverse of our eigenbasis matrix. Finally, since we know that raising this product of 3 matrices to a power n is the same as raising only the diagonal matrix to the power n, since the eigenbasis matrix and its inverse cancel each other out n-1 times, we are left with one single 3x3 matrix. Multiplying that matrix by our vector of original partial fractions of genotypes, we find an explicit formula for the partial fractions of genotypes in the nth generation. Wow, that's so cool, Shadow! I know. There are often a couple other modifications you need to make to your transition matrix depending on what breeding program you're using, as well as what type of gene you're looking at. For example, if you're dealing with an X-linked gene, then generally you would want to use a 6x6 transition matrix that can deal with all 6 possible combinations of male and female genotypes for that gene. But ultimately, you're dealing with the same concept of diagonalizing transition matrices in order to find explicit formulae for your genotype partial fraction vector. And that's pretty much it. Hold up.
See, Shadow. Shh! Just getting curious about something. Shadow, what is it that you found?
I think...
Shadow, do you have a scent? Do you want to follow your scent, Shadow? Go. Let's go. Let's go. Follow that scent.
I found...
What is it that you found,
The
Shadow?
Mini Pups Evil Incorporated headquarters.
She found the Mini Pups Incorporated. She just needs to take a sit down. Because she's just like, so many memories are coming back to her right now. So many memories. Right, Shadow? You're even tearing up a little bit. It's okay, Shadow. It's okay. It's okay.
Alright, we gotta get to work quick if we want to save these dogs. Oh yeah, I can smell exactly 10 million dogs captured in this building. If we quickly calculate how many Uber XLs and Uber X's we need to order, then we can save all these puppies before the evil owners can figure out what happened. Okay, so from what I can recall about the days of my youth, which was about 10 years or 20 breeding cycles ago, there were 10 dogs total from Generation 0. There were no big A dogs, 1 carrier of the mini pup trait, my father, and 9 mini pups total, one of whom was my mother. So we know that we're looking for the genotype partial fraction vector of the 20th generation, that A0 is 0, that B0 is 0.1, and that C0 is 0.9. Substituting into our explicit formula, we find that out of the 10 million dogs that are here, 9,999,999 of them are mini pups. One of them is a carrier. So we should probably order like 1 Uber XL and 1 million Uber X's.
Hasta la vista, baby.
Bro, what are you even doing?